All right, so my name is Chris Wanstrath. I'm a little nervous. I've got like a new operating system. And this is also the first time I've given a talk as kind of like a corporate shill. I don't even know how to say it well. I've given a few talks before, and in all the previous instances, I've always been representing like myself or a consulting company or some big corporation whose website I don't even want you to go to. But this time, I actually have a product that I'm really excited about and want all you guys to use. So I'm going to try not to like hammer it home too hard. But this is the product. It's called GitHub. And one of the things I read when I was researching how to be a good presenter is don't ever talk about yourself. No one cares who you are. Build your reputation by giving a good slideshow. So I'm going to not do that and say, GitHub's really awesome. You guys should try it. And because it's awesome, you should probably listen to this presentation, which is unrelated entirely to GitHub. So that said, GitHub is a Rails site. It's built in Rails. I started doing Rails for CNET a couple years ago. And I'd always done it on the side while I was kind of learning how to program and getting good. And so to me, what was interesting was that Rails exposed to me, or someone like me, a web developer, a really powerful language, a really powerful like programming dynamic language. And so what I did when I was learning Rails was not read the Agile Rails book right away because it wasn't out. I read one of the only 3 books that you could get your hands on, which was the Why the Lucky Stiff's Poignant Guide. And I think if you get all the way through it, and that's like your entry point into Ruby, you come out with a unique outlook, which is, I'm going to write the most cryptic, most insane code I can, and it's going to be really awesome, which is what I do. So what's great about Why's book is it talks a lot about metaprogramming. I think there's a chapter devoted to it. He's got lots of great kind of mnemonic ideas to teach you the basics, but he also has really great examples that you can follow along and use to learn the more interesting things. Like Dwarfme's array is one example. An entire mini site devoted to learning how to metaprogram your own mini RPG. And so to me, when I was in college, when I was trying to learn a real programming language for the first time, all I really had experience with was, like I said, the web and MUDs. So doing this was really exciting and got into my head that Ruby was really powerful because it could rewrite itself on the fly. That's kind of how metaprogramming was presented when you read about it in Wikipedia and all that stuff. So these are the 4 of the however many methods that Ruby gives us that kind of expose the underlying implementation and let us do things that the Ruby implementers can do within our dynamic programs on the fly. Define method, of course. Class new lets us create a new instance of a class. We can pass it another class to be the superclass. Instance of all lets us control the scope of a block or a string in a valet. And send, which lets us send a message, which is kind of getting to the heart of Ruby's small talky message dispatch system. So here's an example of something that I would hope to never see in a Rails app or some kind of production code, but is really quite fun to do. We have a person class. We grab the singleton or the meta class or the eigen class, and we run through either a local variable or a method, which is an array of arrays, the first element being a name, the second element being a proc or a lambda, and we add all these class methods on the fly to this class. There could be thousands in there. There could be tons, literally. So this is really cool. There's a lot of power there. There's a couple things going on. We have to send define method to get around the access controls because define method is a private method. We have to grab this eigenclass tomfoolery, which is probably a whole presentation in and of itself. But another really great thing about Ruby is we can take this and we can make it look normal. So we can open up class, right, which is the blueprint, the class for all the instances of class, which are things like person. And we can add methods to it, which is something that Rails does extensively. Has many, belongs to, and all those are just class methods. And then we get some Ruby that looks a lot nicer. It looks a lot less evil, despite the fact that it still is. So Ruby is very powerful for so many reasons, 2 of which are the amount of change you can inflict on the kind of environment at runtime and how much you can hide that. I mean, we just hid that tremendously. This almost looks normal, but it's really not. And so this is one of the main reasons I love Ruby, all these little side projects you can do for fun that are so far removed from web development or JavaScript, well, not really JavaScript, but so far removed from normal Rails development that it's crazy and it's almost like an entirely different language. So I have this habit of trying to, look for problems that aren't really that big of problems and solve them with metaprogramming. It's just something I'm into. And one of these problems that wasn't really a problem is that doing Rails development, I always have these rake tasks that I move around from app to app. One was like DB version, DB remigrate, and stuff like that. where I could keep them in their own Subversion repository and do like an externals bit, or I could have some bash script to install them, or even a Ruby script that would constantly copy these rake tests over from my existing Rails app or my repository of rake tests to my new one. But that was kludgy. And it also made it harder to share these tasks with other developers or to not share them. Maybe I didn't want to commit all my crazy rake tests into the Subversion tree because they were just for me, or I was too lazy to remove the hard-coded paths to my user/Chris or what have you. So I came up with this idea for this thing called Saki. That's the last effect I'm going to use, I promise. But I had to try out the new keynote. So it's like rake, except the first letter is different. And what it is it's the idea of Ruby gems, or any packaging system really, very lightweight for Saki. It's also really influenced by Git in that it's easy to use. There's no central location. Every single Saki client is also a Saki server. So any file or any page on the web, which is plain text, you can pull in rake tests from. So what I really wanted was, okay, I can share my entire Saki file, my entire rake file with anyone here. There can be 100 Saki tasks in there, and I want you to be able to pick out just one. Now, how do I do that? Well, there's a few different ways. Let's take a look at this pasty patch. I used to get, back in the old days of open source, I would get lots of patches on RubyForge or wherever submitted as pasties. So I had this kind of automated workflow where, all right, I'll pull in the pasty, I'll automatically apply it, I'll run the test, I'll look at it, and then if it's good, I'll commit it, otherwise I'll throw it out. Now, that's actually all built into Git, so this is one of the reasons I wanted to put this in there. Anyway, so you look at this and, how do we get just the body of this one task and identify it so that we can share it using Ruby? We want to save it, we want to be able to install it, uninstall it, send it to someone else, send just one task, send a whole file of tasks. And it looks pretty simple until you start looking at it like this, where the Git format log is kind of written in the curly brace style, and the one above it is all kinds of madness. So, I mean, it's simple, right? I'll use regular expressions. It can't be that hard. I'll find a bunch of rake tasks out there. I'll get a set of regular expressions that handle every case, and I'll be done. But, of course, now I have two problems, which are regular expressions and the actual handling of them. So, of course, I was thinking about this for actually a while. I have another project called Cheat, which is another sort of fixing a really small problem in a really grandiose way. And what it is, it's a wiki. Anyone can go and modify a plain text cheat sheet, and it's there. They can add their own. There's a Git one, a Subversion one, a Rails one, a TextMate one. But it also has a command line client that you can use to pull in the cheat sheets from the website. And because of that, it has an API. You can put it in TextMate. You can put it in Vim. I have a little macro thingy where I can pull in a migrations cheat sheet into my Vim shell whenever I need it. So while I was working on that, I decided that it'd be cool to have like a Saki website and be able to share these with other people. And it'd been in my head for a while. And one day I saw this presentation at a San Francisco Ruby meetup where this guy, Blaine Cook, used this thing called Ruby to Ruby. And so as soon as I saw that, I thought, I know what I'll do. I'll just ask Ruby what the method is. I'll ask Ruby about that task, and it'll tell me, and I'll be able to do all the things I want to do on my own. So it's funny because Ryan Davis is here, and I'm going to be talking about his stuff a lot, and I'm just going to try and pretend like he's not. So anyway,
I'll be nice.
Thank you. Ruby to Ruby is awesome, not just because Ryan's here, because there's this really basic question which is really hard to answer. It's how do we ask Ruby for method bodies, or the bodies of blocks or procs or lambdas in this case. So I have an IRB session here, ask Ruby equals proc, blah, blah, blah. I want to get that self-referential kind of string into something I can use, maybe an array of this or that, or another string that I can reeval and whatnot. So how do I do it? And it's stupid simple. You just install the Ruby to Ruby to Ruby gem, and you call toRuby on your block, and there it is. So that's actually a Ruby string that we get of the method, of the block, and we can do with it whatever we want. So that's just one example of what we can do when we have access to this thing in Ruby, which we know as the Parse Tree. So that's the name of this talk is Forbidden Fruit. There's an apple. I also used the cool kind of like remove alpha effect in Keynote. It's really awesome to get that nice apple gleam. So moving on. Gem install Ruby to Ruby. It has a few dependencies, but the good thing is a few of these gems that we're going to talk about, if you install any of them, they pretty much all depend on each other. So you get it once, you have to deal with 2 or 3 or 4 gems, and then after that, it's a simple matter to install any one of the siblings. Ruby to Ruby is good because it not only gives us the toRuby method on blocks, it also gives us a class method called translate, which we can feed into it any class, and it'll give us the Ruby representation of that class. So I saw Giles a couple of weeks ago at Philly Emerging Tech Conference, which was really awesome because there was about one table of people watching us talk, and it was all the other Ruby speakers. So I was paying very close attention. And what he actually did was he took an active record class, a subclass of active record base, like a person class or a ticket class. He called has many on it, and then he ran the class at that point through Ruby to Ruby, and he saw all the crazy crap Rails did to it. He got his, let's say, has many tickets. He saw his tickets method. He saw his everything from there. You could see the options that it takes, where it goes with it. And it was really interesting to see these methods that you use every day and you know because of the tests you write and the documentation you read in Ruby code, which I've never actually seen before. So that was a really great use of Ruby to Ruby, in my opinion. Something really cool you can do to just introspect code. He's not actually using it for anything, any kind of gem or whatnot yet, but it's a good way to just see what's going on. So back to Saki. I was going to do a little demo to show you guys what it is, but I don't think that this is actually going to work. It worked so well in the hotel. Basically, Saki lets you do a dash capital T just like rake. It lets you do a dash capital T on any other file just like rake to see what tasks are in it. It lets you do a dash capital T on a website, a web page, without caring about the difference and see the tasks in it. It lets you do a dash I to install a single task, to install every task from our Saki file, a dash E to actually print out and examine the source of that task. So let's say you have a list of tasks, maybe 5 or 10, and you want to see which version of get format log is the best, get format log 1 or get format log 2. You can just do dash E get format log, and you'll see the code right there. It's really cool because it just all works. Everything that you would want to do if you were installing and executing arbitrary remote code, you can do. You can uninstall it easily, you can install it easily, you can examine it. It evals things over the wire with the safe level. It's just really great, really simple. And the best part is I wrote it in like in one night because everything is so clean and kind of I just depended on other people to do the hard stuff for me. So to Saki, this is what you write in a Saki file, let's say. This is what you and I see. Task, hello, we all should be familiar with this because it's basic rake. But behind the scenes, what we're doing in order to grab this block of code and be able to treat it as data, foreshadowing, is storing this with our own DSL. So we're not actually using rake when we're running Saki and looking at this file with a dash T. We're actually running our own Saki version of the rake DSL where every task gets grabbed and put into our own task array, the way that they do it, with some extra metadata. So if we were to require Saki in IRB, we could do this. Task equals new hello, hello being the task name, and feed it a body. And when we ran to Ruby on that task, this is what we'd get out. This would be a string. Let's say we're printing it, so it's formatted nicely. But this would be a string of the body. And you can see what's interesting is I didn't have parentheses in my version, but there are parentheses in this version. So it's not actually saving the code that you write. It's looking at something within Ruby, say the parse tree, and generating a string representation of that code, which is wicked awesome. What we also can do, now that we're kind of building things on the fly, is pass in some other information like dependencies and a description, and get out more advanced but very, very common rake tasks where there's a dependency on an environment task, there's a description, and all that sort of great stuff. So that's all I'm going to talk about for Saki right now. It's really great. You should install it if you haven't and use it daily. There's a bunch of tasks for making MERB development easier and using Git easier and whatnot. But even though this is a Ruby conference, there's something that I learned recently. I've recently gotten into JavaScript about the end of last year while I was working on this site, FamSpam, for my other company. And I found jQuery, which someone talked about earlier, Josh, and it's really awesome because it's just very concise, it's very terse, it's very easy to learn. You basically just learn a set of rules, and from those rules, you know everything. You can know where to look for something, you know how to do anything, you know where to go in the documentation, and there's very, very few rules. Everything is very consistent. And so while I'm diving into JavaScript, I'm realizing, oh, wow, this is actually a real programming language. It's not just alerts and equals, and there's actually a difference between using a var in front of it and not. And so one of the things I learned along the way, which I'd never even imagined before, is JavaScript has to JavaScript built in. There's a toString function that's in every JavaScript implementation that's modern. And what it'll do is give you a string representation of the function. So it doesn't work for things that are defined in C, like array size and whatnot. But if I define my own function, I can get back the string from it right there. And what you can do with this is the same thing you can do with Ruby to Ruby. So for instance, Yehuda Katz, one of the MERB guys, one of the engine yard men as well, has a JS spec library, which is a dead simple BDD library for JavaScript. And what he does is print out all the statuses in the console of Firebug, which is pretty cool. But he's able to print out the arity of the function you're calling and the name of the function you're calling by using toString and parsing the first line. So it's really cool. It gives you some insight into what you're doing, especially when you're trying to do kind of debug, development, sort of what's going on here stuff. So Jim installs Saki. That's it. So what else can we do with toRuby? Well, I mentioned it earlier, but Blaine Cook showed me something that was really cool and really opened my eyes to the possibility of using Ruby to Ruby, which is that when you hear about this, there's a gem that can turn Ruby code into Ruby code. You're almost like, oh, so what? Ryan Davis got drunk again and wrote something crazy that I'll never be able to use. But really, I think it takes maybe one of his projects, one of Blaine's projects, or something real, something that's actually being used in a project to see how really powerful it is. So this is one that Blaine did in like 30 lines of code. It's basically the map part of MapReduce, written in Ruby with Ruby to Ruby and ringy dingy. And it's so simple, it's almost beautiful. So what you do is you take a range here, 1 to 100, and instead of calling map on it, you call dmap, which is this method that Blaine has authored. And what it'll do is exactly what you expect. It'll send this block to different servers that are running somewhere in the LAN. It'll ask them to compute it, and it'll get back the result. And at the end, you'll have a 100 element array with all your results served concurrently. The code is not the most beautiful thing to look at if you're not familiar with DRB and ring servers and whatnot. But basically, what Blaine has done here is two really cool things. He's foregone the sort of configuration you need to set up a little cluster of servers by using ringy-dingy. It's kind of like Bonjour for Ruby daemons. So servers can register themselves, and clients can find them, and you can have as many as you want, and there's no sort of, OK, I need to connect to this IP on this port, this IP on this port. It just works. So what Blaine does is connects to a ringy-dingy server, or instantiates a ringy-dingy server, and looks for some other clients. Actually, this is not using all the code, so I'm confusing myself. But the ringy-dingy server is a client. He attaches to the server and asks it to do something for him. He then collects the results and returns them as an array. And what he's asking the server to do, what he's asking the server to perform, is really interesting. Because he's saying, here's this block of Ruby code as a string. I'm going to send it to you. I want you to eval it and send me back the results. This is over some sort of very secure network, hopefully, so it's not that big of a deal. But the clients are identified by their PID. It sends over the Ruby, it's executed. The element also gets sent over in the sort of DRB serialized fashion. And what you get back are the computed results, which is really quite cool. Here's the actual server end of it. And it just starts a ring server. What it does is it takes these strings off the wire and evals them and passes in the element it was sent. So if it's 1 to 100, each time the block gets sent along with the element 1, 2, 3, 4, evals it, and then sends back the answer. So it's really cool. It's just the map part of it. I'm sure no one's using it. Well, maybe Twitter is using it, but I'm sure no one's using it in production. However, it's just a kind of example of the neat things you can do with this sort of power, mad power. I put it up on GitHub last night because there is no reduce part of it. So it'd be cool if someone wrote that. I might do it later this week just to see if I actually understand what's going on. But there it is, grab it, AutoCAD approved. So what else can we do? Well, it's kind of switching gears here, but what we're talking about is kind of beyond metaprogramming. Because metaprogramming isn't really that big of a deal or that distinct from Ruby. Someone said that metaprogramming is just programming in Ruby, which is true. The methods that I showed earlier, the instance eval, the define method, and those are well documented, those are well written up, blogged about, those are part of Ruby. So when you use those and you're coming from another language, they're magic. But once you start doing Ruby for a long time, they become something you kind of depend on in those edge cases, and there's something that's always there. They're not special, they're just a part of Ruby. Ruby is just so dynamic that things are always changing, and you don't really even think about, OK, now I need to switch into metaprogramming mode. However, there are things you can't do. There are limitations, and there are things that would be really cool to do, but you just can't. And what's really frustrating is that in other languages, some of these things are possible. So what am I talking about without using such abstract verbiage? Here is one. This is kind of an idea that's not original at all. It's how can I make my crappy SQL strings more expressive and more pretty with syntax highlighting and whatnot. And the way to do it is write it in Ruby. So here's one attempt. It's called the conditions builder. And there's a plugin on the Agile web development kind of plugin repository. And what it lets you do is spend time learning an entirely new API for the added benefit of some really weird syntax. But it's a cool attempt. It's writing your conditions in Ruby. It's compositional, so you can take different condition objects that you've created and mash them together and get a new condition object. It's probably very easy to mock and test and assert that the SQL you're generating is the SQL you actually want to generate on the SQL generation level, aside from the whole Rails active record plumbing level. And it's a neat idea. I mean, the problems are obvious, is that you have to learn this whole new API, and it's not that intuitive. The and, I think, refers to the next one, the next statement in the list. So it's just not the way that you would write other Ruby. It's not the way you would write something to interface with Saki or something you would write in your action controller. But it is definitely interesting. This is another earlier attempt, which is actually pretty popular. And the README file is really long. It can do a ton of stuff. It's called EasyWare. It's by Ezra and Fabian, someone, his last name escapes me. But it's actually kind of difficult to Google for. Just go to the Agile web development website and type in easy, and it should be there. But what it lets you do is the same kind of thing. It's let's create our own sort of Ruby DSL, and let's be able to create SQL conditions using it. Again, the advantages and the disadvantages are obvious. It's cool. It's compositional. It lets you do very, very complex things with EasyWare. It's aware of Rails, so you can pass in things like include after the all symbol to do your joins and whatnot. But it's a whole new thing to learn. It's a really long README. It's very powerful. And the simplest solution, I think the thing that all of these kind of query generators and Ruby kind of layers on top of SQL are trying to do is something like this. Oh, I spoiled it in the bottom. Anyway, this is just Ruby. This is the way we would operate on a hash, on an array, on anything that's enumerable. In this case, looks like an array of, let's say, OpenStruct objects or person objects. And it would be really great if this is how we could write our SQL, because not in all cases, but in some cases, this is really all you need. The username is this, the user login is this, the user password is this. I don't care at all about active records, find all conditions, or find all by whatever API. I just want to write in something that's very simple and instantly recognizable. And there's a lot of benefits that go with this, because there's very slow learning curve. If this was, say, the API for a number of different ORMs, it would be very easy for you to dip your toe into a new one and then kind of get into the hardcore API. So before investing a lot of time, you can focus on how do I get it set up, how do I get it to know where my database tables are, how do I get to do this sort of back-end stuff, and then as soon as that's finished, bam, I can do my queries. I can start using it. Whereas now it's all pretty much very well documented as far as like data mapper and SQL phonetic goes, but there is the step of actually learning and reading the cheat sheets and that sort of thing, which, I mean, I hate to learn. So this is kind of, in my mind, the gold standard for simple queries. And what's interesting is, again, this is something other languages already do. If you've ever used Erlang, they have this sort of half memcache, half relational database thing called Amnesia. And it's really interesting because Erlang has built into the language list comprehension, which is a very technical sounding word for backwards-ass enumerables. And what they do is kind of filter their arrays after the array has been kind of declared in these little conditional blocks. It's hard to explain, but once you see it, it makes a lot of sense for us. It's, oh, there's a greater than condition followed by a less than equals than condition. They're doing a select. And what they're doing in this very terse syntax is filtering out records. So since they already used that for lists, they decided, let's use this to query our database. We can treat records and tables as lists, and we can write this query in this language we're all familiar with. And what we can do behind the scenes is translate it into a more specific Amnesia query language. So the important thing about this is the behind the scenes querying. I mean, we could pull out every single user in the database and just run them through this and say, oh, we're done here. But that's just not going to work for even pretty small data sets. So what we need to do is be able to look at what's going on here and make this into SQL. We want to turn this into SQL and then run the SQL. That's exactly what we want to do. So the way that I've solved this problem is with this gem called ambition. And this was kind of just noodling around, learning Erlang off of the pragmatic book, and reading that, okay, what they do is they have their list comprehension kind of code here in natural Erlang. Amnesia walks it's actually called QLC, I think. It's a query language for Amnesia. There's different front ends. But the QLC walks the parse tree and makes the query from that. So the code that you write, the list comprehension, never gets run. I was like, oh, that's perfect. That's exactly how to do it, because that's what you can do with Parse Tree. So this is the active record kind of find, the very simple one. It's a lot of cruft because, well, it shouldn't be in all, but whatever. Anyway, there's a lot going on for something very simple. I want to find John. And what it does is it generates the SQL behind the scenes. This, I think, is so much more clear to someone that's doing Ruby. And for this case, it makes a lot of sense. It's very explicit. It's exactly what you want. And it doesn't kind of contain any of the ORM-specific overhead. And what we can do with it is generate a SQL string like this by giving the user class a little bit of magical powers. So here are some of the things that Ambition can currently do. One of them is this more, if you guys can't read it, all these slides will be up post-haste, so just bear with me. But what we're doing here is a select on users. We're passing an arbitrary array of Ruby. We're saying, is this user's ID in this array? And I think that's a really cool one because it's not the basic, user.name equals Chris. It's something that's very, very Ruby-ish. I mean, the ID isn't even on the side that we think it would be on for an in clause in SQL. It's just exactly how we write Ruby. On top of that, we're giving it to an instance variable, and we're adding on more conditions later on. So it's composable. The conditions kind of stack up and can be merged together, just like with the other condition builders. And what we're saying there is, all right, if that ID is in that array, or any IDs that are in that array, I want them sorted by reverse age and name. This is, I think, very clear to any Rubyist. Even people that are just learning Ruby, you're kind of faced with the enumerable API very early on because it's awesome. This is literally what this gets translated to behind the scenes, aside from some SQL database-specific quoting. But exactly what you would expect. And to do that in active record, I'm sure it wouldn't be impossible, but I didn't even want to have to think about it and write the example slide, so you guys don't get one. This is another example, and it's cool because it's not just select. I mean, we want to use detect on top of select, even though we can say like select.first. Detect has a very specific meaning to Rubyist. It's return nil or return something. So I want to detect the user who has an idea titled new freezer and whose email matches the regular expression, PJ. It's also a regular exception in my code. But this is what that would translate to behind the scene. Mountains of joins, because we're going across both profile and ideas, which, if this is active record, are associations. So now what we're getting into is sort of all the stuff on top of the little bit of magic. Ambition's a bit more complicated than Saki because there is this merging of whatever the Ruby stuff we have to do with Parse Tree and all the Ruby to Ruby goodness, and also the active record. So active record has its own sort of way of generating queries and its own join generation and that sort of thing. And what we can do, luckily, with normal Ruby programming or meta programming is treat the array, treat the association specially, and look for certain things in our block of code and know that, oh, this isn't an ideas property. There's a has many called ideas, so let's go through that and generate the SQL and whatnot. So it's pretty cool. Also because we're using active record, we can tell which database we're in. So we can do database-specific stuff. Like that's a Postgres-like expression with the tilde. In MySQL, it would be like all caps like. No, it would be all caps are like because it's a regular expression. So here's the final example before I'm done boring you guys with this stuff. But I thought it was cool because it's going through an association and then calling a method, just like normal Ruby, something that we'd probably be able to do. Profile email downcase is matching Chris and give me the first 20. And because we have all this power, we can actually look into the database and see its equivalent of downcase and say, all right, it's lower, just put that junk in there. And then, OK, this isn't another example. So why is this so hard? This is so simple. It's two very simple kind of conditions in a block. What's so hard about this? Why can't we have like a crazy blank slate proxy object to collect what's going on, and then after the block has some method called on it, do some, you can't. Okay, you just can't. So there's a couple things here. The first one is the double equals operator. If you leave it the way it is and you don't kind of get into the core Ruby and take it over, what you're going to get out of that is a Boolean. It's going to be true or false. You're not going to be able to kind of treat the double equals operator as something that collects information without distorting the Ruby runtime and what's expected in that context or other contexts. So that's one thing you can do. You kind of override the double equal with messiness. And the other thing is this double ampersand. I mean, you can't. There's no way to do this in Ruby proper. Stock MRI. If you run this code, you get a syntax error. It doesn't even know what the hell you're trying to do. TextMate can't even figure it out. But there's certain things in Ruby that you just can't override because they're built into the grammar. And this is one of them. Specifically, these are the other two. The bang operator is actually a lot more complicated and malicious than it seems. It's really hard to kind of deal with it when you're getting into these kind of lower level things. And there's just no way to kind of see a not in pure Ruby with metaprogramming if you have something like a bang in front of a conditional. So, however, luckily for us, there is Parse Tree. And Parse Tree lets us get away with all the things our mom and dad told us not to do. And like Ruby to Ruby, it's crazy when you first install it how simple it is. What you do is you take a block, and I don't actually remember if this is something I added or something that's in Parse Tree, but anyway, it's trivial to do. Take a block, for instance, call toSexp on it, and what you get back is this crazy looking data structure. But what it is luckily just a normal Ruby array with normal Ruby symbols and types in it. That's a real nil, that's a real integer 1, those are real symbols. So let's focus on the meat and get that kind of implementation cruft out of there. This is the parse tree for 1 plus 1. All right, so what I think I'm good at is kind of like taking the stuff from the smart guys and like looking at it for a couple years and then figuring it out just enough to use it. So I'm not actually an expert on languages or abstract syntax trees or context syntax trees and that sort of thing, but I've read Wikipedia and I've been working on this thing for a while now. So this is my interpretation of it. It's very kind of basic, but there's a wealth of information on compilers and parsers and just in the Rubinius community, like what is actually going on behind the scenes here. So what this is, what we're looking at, and what Parse Tree does is it kind of hooks into the abstract syntax tree, which is what Ruby generates when it kind of parses your plain text file. So it takes this human readable text, this Ruby language, and it builds in memory like a semantic representation of what's going on. You could have different things in Ruby, like different ways of writing the exact same code, and chances are in the abstract syntax tree, they'll be represented the same way, because it's the same code, despite whether you use parentheses here and not there and that sort of thing, which we kind of saw earlier. I did a puts without parens, and on the other side it came out with parens, because Ruby semantically doesn't care about whether they're there or not in that situation. So what you get here is a Ruby representation of the abstract syntax tree. There's also this thing called the concrete syntax tree, which in my understanding includes the information about the parens and whatnot. And when you're dealing with grammars directly, there's one available for Ruby called treetop. That stuff is more visible to you, and we don't care about that at all for what we're doing. So luckily, Parse Tree either omits it or never sees it. I don't actually know. So to get a little bit more academic, I don't know if you guys are still with me. I know I'm very highbrow here, but this is the classic kind of diagram for what is being represented in a parse tree. Right? It's 1 plus 1. It's in every language, mostly written something like this. And what you get back is this array that we saw, and it's prefix notation. So the elements that go before other elements kind of describe what's going to happen to the ones that are nested within them. And here's the representation of that. So there's a call, something is going on, and in this case, we're taking a literal, and I think using a plus with it and passing it an array of arguments. One of the things I learned about Ruby while I was doing this parse tree stuff is that arguments are always an array, I guess, because that's what the node comes out as. So that's probably why we get goodness like the splat operator in argument passing and that sort of dynamic stuff. It's because Ruby just kind of defaults to an array somehow internally. So that's an interesting thing you kind of pick up when you're dealing with these arrays you get back and data structures you get back. But that's basically it. This is what Ruby sees, and this is how Ruby decides I'm going to call this method with these on this kind of literal with this other literal being passed to it. This is a bit more complex, barely. And it gives us a little more insight into the kind of prefix notation nature of the parse tree. And what we're actually looking at are what's called S expressions. I believe the S stands for symbolic. And these are kind of a Lispy thing that we'll talk about in a little bit. But this is like an S expression in Ruby here, hence the 2sexp. It has nothing to do with the actual sexual appeal of the code, despite what you may think. So here, the basic thing is that the and is before the two clauses, which are both double equals. So it's like and goes first, and I need to and both of these underneath it, right? So it's prefix notation, which when you're writing Ruby all the time and never having written Lisp or anything like that before, it's kind of hard to get your head around because you have to write your code a little bit different when you want to process these arrays. And once you get used to it, you start being a little bit like arrogant about it, like, oh, it's the only way to write code, but that's not true. All right, so we have this, right? We got this. This is the easy part, 2sexp. How do we process it? How do we handle the crazy notation and what's DAG syncur and all this sort of madness? How do we filter out the stuff we don't want? What do we do with it? How do we generate SQL from this, really? That's the question. And this is the way I originally did it with Ambition. So Ambition is two separate projects that have the same name. And the way that it works is that one is a newer version than the other. So originally, Ambition was just an active record kind of plugin. You can install it in your Rails app. You could launch it on your servers with Ruby inline, doing the parse tree stuff. And you can just start replacing active record.find calls anywhere in your app selectively. I actually used it on that other app I talked about before, Cheat, was kind of my proof of concept. I just went through my little camping app, and I just replaced every single SQL call that was read, any sort of read calls, no write calls, with a select or a detect or whatever. And it worked, and it didn't leak memory. So what the hell? Rake release, right? So the way we had to do it originally was by writing a sexp processor. One of the cool things about Parse Tree is I don't know if it's still in there by default. It might have been split out. But it used to come with this thing called sexp processor, which is a class that is good for helping you not only deal with structures like this, but also learn how to deal with them. Because in my experience, I don't know if it's intentional or not, it's really, really strict about what you do with this. It has lots of error checking. It yells at you if you don't do things the way it wants. And I was kind of annoyed at that, by that at first, but then when I started to write my own processor, I realized, oh, well, that's just how you learn. And it's a really good tool for learning. So it's called the sexp processor. And what it does is it kind of teaches you this pattern. I don't know if this is the exact pattern in this slide, but it teaches you this pattern of you take a class, you give it some Ruby code that you want to translate, you squeeze a sexp out of it. Maybe you pass the sexp in. It's irrelevant. And what you do is you process this sexp running through the array, shifting off the first element, and doing stuff with it. So in this case, the way we're going to set up our block to SQL processor is by making a new class, setting up the initialize method, keeping that block around because we're going to use it more than once, and giving a toSQL or toString or inspect or whatever you want method that actually does the processing of the sexp when it's called. So you make the object, you deal with it however you want. Maybe you never use it. You don't actually have to go through the processing until you call this method. So one important thing to point out here with this parse tree kind of voodoo is I've seen it said on the mailing list and whatnot that parse tree is slow, and I've seen Ryan be like, you're an idiot. And I've actually run a bunch of benchmarks and tests, and I can confirm that you're an idiot. It is not really slow at all. It's pretty quick because I guess it just hooks in information that's already available. So parse tree isn't something that you can't use on a production like Rails app. When I used it, there were no memory leaks. It was very quick, and it was just a pleasure to use. So unlike Ruby to Ruby, which might be kind of nerve-wracking, generating and evaluating Ruby on the fly, parse tree is totally good to use in any sorts of wacky situations, including MERB, the wackiest of all situations. In MERB more, they have this really cool parse tree dependent thing for getting arguments to line up with Git parameters. And as far as I know, there's no problems with it, and I wouldn't see why there would be on the parse tree side. So it's cool, and as this gem becomes more popular and people are kind of getting tired of defined methods and that sort of thing, reaching out to do more with Ruby and kind of be like the other cool kids like Erlang, I think a lot of these kind of gems will pop up more and more. Anyway, I digress. So here's our simple block to SQL processor. And we're going to use it like this, basically. We're going to pass it a block, yada, yada, yada. In our code, we'd probably do it like this. We're not actually going to interface with this class on the command line or from clients or that sort of thing. But here's what we do. We get the block, we get the sexp, and we pass it into this process method. So we're passing in that big, crazy kind of blue-looking array to process. And what are we going to do with it? Here's my slimmed-down version of the process method. And this is what I mean by the kind of idioms that this XP processor sets you up for. So this is without any kind of real error checking or whatnot. It just does what it does, and that's it. What we do is we take that array, actually. There's the array on the bottom. Sorry for anyone who can't see. But we take the array, and like I said, we run through each one, each sort of element in it. We take the first element, which is hopefully going to be a symbol, and we say, is this, well, an array. Is this an array? Is the first element a symbol? If so, do I have a method called process underscore whatever? And if I do, I'm going to call it and pass it the rest of the array. So it's basically like a kind of head-tail situation. If I respond to the head, pass it the tail. And what that gives you is the ability to write methods like process underscore dragon underscore cur and have it accept an expression without that kind of identifier and do what it knows it can do with it. Call, and all these are examples of methods that you kind of have to write yourself if you're writing a processor from scratch. So here's what that looks like. I wrote the dragon cur. It sets a receiver instance variable, so we always know that if any methods are called in the block on this u local variable, that we're actually trying to operate on the table, and we want to do sort of SQL magic stuff. We know if it's an ivar in the block, it means that we're trying to like do Ruby stuff, so just eval it and get the contents and that sort of thing. For the original ambition, I wrote like a whole bunch of this stuff specific against the parse tree to generate SQL, and as Giles would say, dude, like it became a pain when I wanted to add like data mapper support and Postgres support because I realized I was like, wow, I'm really not that excellent at this parse tree stuff, nor the SQL stuff, and I'm doing both of them at the same place at the same time. Maybe this is a time when I should separate the two. And so what happened on the plane home from RubyConf was ambition adapters. And I got this crazy idea that, all right, here's what ambition is. There's a very specific use case here. I want to have a select, I want to pass it a block, and I want to generate a string and send that string somewhere. So the way that we do that is with translators. It works. You can gem install it right now. And the way, just as an aside, a BDD kind of thing, it was cool because I had all the tests for the active record adapter, or the active record version of ambition. I should have just named it something else. I just took the tests, started fresh, and just wrote the code till they passed. I didn't have to write any tests on the airplane. It was a beautiful thing. This is what a translator looks like, right? So the idea is that you're always going to be writing an interface to query something, like SQL or LDAP or Sphinx or something like that. We always want to query something with ambition. It doesn't do write operations. It doesn't do any of the other crazy stuff. Just selects and detects and enumerable. It's Ruby enumerable. So here's what you do. You write a translator class. You say, all right, for less than or equals to, return this string. For include, do this junk, return this string. If it's down case, do this junk and return this string. And ambition kind of is the thing handling the parse tree now. So I can write as many adapters as I want and work on my adapter as much as I want. And I don't have to ever worry about parse tree from that kind of that code. It's separate. What ambition itself does is, it looks through the parse tree, it handles discrepancies, it knows what's going on, and it fires off methods on your translator, takes the strings back, and kind of builds them up. What you also give it besides a select translator, a slice translator, and a sort translator for sort by, slice, that kind of stuff, it's a query translator. So when it's all done, you get this query object. And what do you do with it? You call first on it maybe, and then the SQL query fires off, or you call like .each on it, and then the SQL query falls off. So the cool thing about ambition is this kicker concept where maybe you set your instance variable in your controller action, and you have your view logic cached. Well, in normal Rails, that DB query is going to get fired off whether the view logic is cached or not. However, because of the kind of on-demand processing style that parse tree has and kind of encourages, we don't kick off the SQL query until it's asked for. So that means we can do this composition, we can build things together, and we can also have really brain-dead caching. We're just asked to write the actual kicking ourselves. So there's this special kick method that we use to do the find. And then any other methods on this query object just get passed through. So your query object can have all sorts of special behavior you want it to have, and all you need to do is just code against this class, and ambition will set it up for you. For instance, if you look, when I kick an active record adapter, I'm calling toHash on the query object, which needs to get all the conditions and do all the includes and that sort of thing. It's not actually generating SQL. So ambition doesn't actually generate SQL and pass it to active record. It builds an active record dependent hash with a condition string and an include string and that sort of thing, and passes that to active record. However, for the presentations and the Blazor and stuff, we have this toString method to generate a SQL query that we're never going to run. So this is how all the documentation and stuff is written. But we never actually run the SQL query because active record does such a better job at generating joins and knowing about dependencies and whatnot. And with this kind of adapter sort of API around Ambition, it's not that hard to take advantage of. I think I'm running out of time, so I'll just skip through this and get to the good part. Since they're just strings, we can generate LDAP, whatever we want, which I already said. There's an LDAP adapter, and it's not that hard to roll your own. We have an app generator, which is a Ruby gem generator, so you can call ambitious adapter from the command line if you have the gem installed, and pass it something like ambitious apricot, and bam, you have like a full skeleton for an adapter. All the classes you need are there. All the methods are stubbed. There's specs for like everything that you would want to do if you're doing it in this kind of classical way. And if not, you can go your own route. There's also a CouchDB kind of adapter that's being worked on GitHub, and a Sphinx adapter that I don't know if it's worked on anymore, but it's a pretty cool idea. So this is back to Ruby to Ruby. Ruby to Ruby does the same thing, basically. It's a lot more intense because it knows a lot more than just select, but it calls sexp on the Ruby code. It has process methods. This is one from Ruby to Ruby for process the module sexp. And then it just spits out a string. It builds up this string and passes it out. It's like really simple, and it just works really well. Here's another one for regular expressions, just to show it's just a string with a left-hand side and a right-hand side. So finally, other parse trees. These are some of the languages. I did like a Google search last night, and like on the first page I found parse tree information for all of these, like how to get it in C++, how to get it in Java. All the Java IDEs kind of support it really well, including the JRuby Java IDEs have support for the Ruby syntax tree and what's going on where. Python, Erlang, JavaScript you can get, and of course, Lisp, the Chuck Norris of programming languages. The Lisp guys are so hardcore because they're not actually writing code. They're writing S expressions. So this is the parse tree for this scheme factorial. This is it. There's no difference there. So this whole code is data sort of thing that these guys go on about, this is it. I mean, they can do whatever they want with this after the fact because to them, there's no difference. Lisp is list processing, I think, and that's it. It's just processing lists. So there's some Lisp implementations in Ruby. One is Bus Scheme by Phil Hagelberg, which is awesome. It's a lie apparently, but it's got some cool momentum behind it. Jim Wyrick has a Lisp.rb, which is just a little kind of fun hack you put on his blog. You write it in kind of a mixture of method calls and arrays. And then I alluded to Treetop. Me and Tom, Preston Warner, as our kind of like side project, are writing this thing called Oil, which is a prototype-based Lisp in Ruby using Treetop. I was going to have it ready for tonight, but then I got on this whole website thing with GitHub. But it should be out soon, and it's really cool, and it's surprisingly simple. And that's pretty much it. These are some resources you can get to. Wikipedia has, as you can imagine, so much stuff on all this kind of esoteric crap, but it's really interesting. And thanks. Anyone have questions? No? Yes, sir, in the back. Stand up. Oh, yes.
I said I'd be nice, so I'm going to be nice. One thing that you didn't touch upon that I think is actually really important for the Ruby community to know is that Parse Tree has a really big limitation, and that is that it does not work and will not work in Ruby 1.9 because the internals aren't there. Because Ruby 1.9 compiles to bytecode, the AST is not internalized and it's not kept around. So none of the code that's based off of Parse Tree is going to be able to work in Ruby 1.9 if and when we transition on the Rails side to 1.9 for deployment.
Yes, that's a mission on my part. You're right, of course, and I just kind of assume we're all moving to Rubinius anyway.
Well, right. The other possibility is that we use my other parser, which is Ruby parser, which actually parses the Ruby code, but then you don't get the toSexp on procs because I don't know what proc you're talking about at the time that I'm parsing whole files.
Yes.
So it's just wonky.
There's also a Ruby parser that he wrote in Ruby, and it's really cool because it lets you do things like pass a string to this like parse tree binary script on the command line and just get the parse tree printed out to you. You can do all sorts of things like parse tree from string and whatnot using this parser. And on Rubinius has a toSexp built in also. It's just always there. You can call any string of Ruby code, you can call toSexp on it and get the parse tree for that in the same format. Anyone else? One more question. Yes.
Okay. Just to clarify that you are able to continue using parse tree or code which depends on parse tree if you're using Rubinius, like going forward.
Yeah.
Okay.
Yes. Answer is yes. All right. Thanks, guys.
You won't actually be using parse tree. You'll be using Rubinius.
Okay.
All the features are there.
I mean, you can still get Ruby to Ruby.
Thanks, Chris.